Quantitative ability problem on trains. This topic is basically the extension of time and distance because the concepts that are learned in time and distance will be also used in this topic. What three variables are involved here are speed, time and distance. Distance is a product of speed and time. Speed is equal to distance divided by time and time is equal to distance divided by speed. Now in the problem of trains, we have to convert the speed units either in from meter per second to kilometer per hour or from kilometer per hour to meter per second. To convert from meter per second to kilometer per hour, we need to multiply it by 18 by 5. And to convert back from kilometer per hour to meter per second, we have to multiply it by 5 by 18. Let us understand one by one case of train, which will clear your concept. The very first case I am going to discuss here is a train crossing a standing man. Now this is a train of length L and moving at the speed of S. Now there is a person standing here and observing this train. The question is how much time the train will take to cross the standing man. Obviously the time taken by the train is to overcome the complete length of the train divided by speed of the train. So time taken is length of the train divided by speed of the train, that is L by S. Please note that this is the time taken to cross a standing man or an electric pole or even a tree. Let us understand case number 2. Train crossing a bridge. Now the person doesn't have any length or a negligible length, but a bridge, when we talk about, it has a substantial length. So obviously the time taken by the train to cross a bridge will be definitely more than time taken by the train to cross a person standing. Now how much time it will take? Here the time taken is equal to length of the train plus length of the bridge divided by speed of the train. Please note that this is the time taken to cross a bridge or even a platform or even a tunnel, because bridge, platform, tunnel has substantial length. Case number 3. Train crossing a running man. Now this time the man is not standing and observing the train. The man is running along the direction of the train with the speed of m. Now the question is how much time the train will take to overtake this running man, considering speed of train more than the speed of running man. If they are going in same direction, the time taken by the train to overtake the running man is length of the train divided by relative speed. Now why relative speed? Because there are two moving bodies and they are going in same direction. So relative speed will be difference of their speed, that is speed of train minus speed of man. Suppose the man is running in the opposite direction, then how much time the train will take to cross this man? Obviously it will be a lesser duration compared to same direction. The time taken is equal to again length of the train divided by relative speed. Here the relative speed will be addition of their speed as they are going in opposite direction. So here the denominator is s plus m, so time required will be obviously less than the upper case. Please note that this is the time taken to cross a running man or even a cyclist or a car, because in the problem of train we assume that there is a negligible length of man or even a cyclist or a train compared to length of the train. Case number 4. Train crossing another train. Now there are two trains. The first train is having a length of L1 and moving at the speed of S1, while the second train is having a length L2 and moving at the speed of S2. How much time the train 1 will take to overtake train 2 if they are going in same direction? Obviously here the time taken is addition of length of both the trains, that is L1 plus L2, divided by their relative speed. Now the relative speed will be difference of their speed as they are going in same direction. What will happen if the trains are going in opposite direction? How much time will they take to cross each other? If they are going in opposite direction, the time taken is equal to addition of length of both the train divided by relative speed, which will be taken as S1 plus S2 this time. So these are the 4 cases on which numericals are generally asked in your competitive exam. Let us quickly summarize what we have learned from these 4 cases. Case number 1, a time taken by a train to cross a standing man. Case number 2, time taken by a train to cross a bridge. Case number 3, time taken by a train to overtake or cross a running man in either same direction or in opposite direction. And case number 4, time taken by a train to either overtake the train in same direction or cross the train which is coming in opposite direction. Now on the basis of this, let us try out some numericals. Problem number 1. A farmer standing near the railway track observes that a goods train of 25 wagons crosses him in 30 seconds. Find the speed of goods train if the length of each wagon is 8 meters. First of all, we should calculate how much is the length of the train. So what will be the length of the train? It is equal to number of wagons which are attached to it multiplied by length of each wagon. So there are 25 wagons and each wagon is having a length of 8 meters. So obviously the length of the train will be 25 multiplied by 8, which is equal to 200 meters. Now we need to determine here the speed of goods train. What is speed? Speed is equal to distance divided by time. Now the distance is nothing but the length of the train. So speed of the train is equal to length of the train divided by time taken, that is 200 meters divided by 30 seconds as mentioned in the question, which is 20 by 3 meter per second. Now if you observe all the options given here, A, B, C and D, they are in kilometer per hour. So there is a need to convert meter per second to kilometer per hour. How to convert from meter per second to kilometer per hour? We need to multiply it by 18 by 5. So if we multiply 20 by 3 with 18 by 5, we get the answer in kilometer per hour, which comes out to be 24 kilometer per hour. Option A is a right answer. Problem 2. A person standing on a platform observes that a train crosses him in 16 seconds and the platform in 30 seconds. If the length of platform is 350 meters, then what is the speed of the train? Well, you can pause this video and try the question on the paper, and once you have solved it, you can again resume the video to look for the solution. Okay, now what is given in this problem? The person is crossed in 16 seconds only and the platform which is of length 350 meter in 30 seconds. What does it mean? It means that to cover 350 meter the train requires extra 14 seconds, because वो person तो 16 सेकंड में क्रॉस हो जाता है, लेकिन यहाँ पर 30 सेकंड लगते हैं, यानी कि 16 सेकंड से 14 सेकंड ज्यादा, 14 seconds extra. So to cover 350 meter, the train requires extra 14 seconds. So what is the speed of the train? 350 meter divided by 14 seconds, which comes out to be 25 meter per second. By multiplying it with 18 by 5, it comes out to be 90 kilometer per hour. Problem number 3. A super fast train of 100 meter covers a distance of 120 km in 1.5 hours. In what time will it cross a bridge which is double the length of the train? Well, what is the speed of the train if it is covering 120 km in 1.5 hours? It will be 120 divided by 1.5, that is equal to 80 km per hour. Now, this 80 km per hour, let us convert it to meter per second by multiplying it with 5 by 18, and it comes out to be 200 by 9 meter per second. Now What is the length of the bridge? Obviously, it is double the length of the train. So I will take it as 2 multiplied by 100, that is 200 meter. Now we need to determine here what is the time taken to cross this bridge. So time required to cross the bridge will be length of the train plus length of the bridge divided by speed of the train. That comes out to be 13.5 seconds. Option C is the right answer. Problem number 4. A man sitting near the window of a passenger train observes that a goods train running in the same direction on the parallel track passes him in a minute. If the speed of passenger train and goods train are 60 km per hour and 90 km per hour respectively, then what is the length of the goods train? You can pause the video and try this question on the paper, and once you have solved it, you can look for the solution. Okay. So goods train passes the person sitting near the window in 60 seconds. Please remember one point here. Goods train is only passing the person sitting in the window in 60 seconds, not the entire passenger train. So ये 60 सेकंड में सिर्फ वो पर्सन को पास कर रही है, पूरे पैसेंजर ट्रेन को नहीं. So time to pass is equal to length of the goods train divided by relative speed. So time to pass I will put here as 60 seconds. Length of the goods train we need to determine, and relative speed will be the difference of their speed because both are going in same direction. As this relative speed is in kilometer per hour, to convert it to meter per second, I will multiply here with 5 by 18. Solving this, the length of goods train comes out to be 500 meters. Option D is a right answer. Problem number 5. A train 180 meter long passes a signal pole in 18 seconds and another train of same length traveling in opposite direction in 8 seconds. The speed of second train is how much? Now this is a train of length 180 meter and it crosses a signal pole in 18 seconds. So we can determine its speed, that is its length divided by time taken. यानी कि 180 meter divided by 18 second. So the speed of first train comes out to be 10 meter per second. Now this first train crosses the second train coming in opposite direction in 8 seconds. So we can build the equation as like this. Length of train 1, that is 180 meter, plus length of second train, which is same as the first train, that is 180 meter, divided by relative speed. So पहले ट्रेन का स्पीड है 10 मीटर पर सेकंड और दूसरे ट्रेन का स्पीड हमको पता लगाना है. So I will write here as S2. I will do addition of their speed because they are coming in opposite direction, and the time required is 8 seconds. So length of train 1 plus length of train 2 divided by relative speed is the time taken to cross, that is 8 seconds. Solving this particular equation, the speed of second train comes out to be 35 meter per second. Multiplying it with 18 by 5, it comes out to be 126 kilometer per hour. Option D is the right answer. Problem number 6. A train overtakes two persons who are running at the speed of 1 meter per second and 2 meter per second in the same direction in 12 and 15 seconds respectively. Find the length of the train. Let us assume the length of the train as L and the speed of the train as S. It overtakes the first man with the speed of 1 meter per second in 12 seconds. So it can be given as length of the train divided by relative speed, that is speed of the train minus speed of the man, and the time required is 12 seconds. So we can write this equation as L is equal to 12 multiplied by S minus 1 here. Similarly, it overtakes the second man who is running at a speed of 2 meter per second in 15 seconds. So the equation can be written as L divided by relative speed, that is S minus 2, that is equal to 15 seconds. So we can write this as L is equal to 15 into S minus 2. Now looking at both these equations, first and second, the left hand side of both the equation is same, so we can equate their right hand sides. So I can write 12 into s minus 1 is equal to 15 into s minus 2, and solving this we can determine the speed of the train, which comes out to be 6 meter per second. Now if we substitute the speed of this train in any of the equation, let us say first equation or in second equation, we can determine its length, which comes out to be 60 meters. Option A is the right answer. Problem number 7. Two trains of length 200 meter and 100 meter simultaneously enter a tunnel of length 300 meter from opposite ends at the same time on the parallel tracks. The respective speed of two trains are 36 km per hour and 18 km per hour. After how much time from the instant the two trains enter the tunnel will the tunnel be free of traffic again? I request you to pause this video and try the question on the paper. And once you have solved it, you can again play the video to look for the solution. Okay. Now speed of train 1 is 36 km per hour. If we convert it to meter per second, it comes out to be 10 meter per second. And speed of train 2 is given as 18 km per hour, which comes out to be 5 meter per second. Now, this is the tunnel of length 300 meters and the first train of length 200 meter enter from this end. Its speed is 10 meter per second, and the second train of length 100 meter enter from the opposite end whose speed is 5 meter per second. Now we will find out how much time train 1 will take to come out of the tunnel, and then we will find out how much time train 2 will take to come out of the tunnel. Time for train 1 to exit is length of train 1 plus length of tunnel, that is 300 plus 200 divided by the speed of the train, which is 10 meter per second. So train 1 will take 50 seconds to exit the tunnel. Similarly, time for train 2 to exit will be length of tunnel plus length of train divided by speed of the train, which is 5 meter per second. So train 2 will take 80 seconds to exit the tunnel. Now the question that is asked here is, after how much time from the instant the two train entered, the tunnel will be free of traffic. So obviously the tunnel will be free of traffic after 80 seconds, which is maximum of the two timings. Speed ratio. There are two trains T1 and T2. T1 P से Q जा रही है और train T2 Q से P जा रही है. Let us say they cross here, somewhere here, and after crossing, train 1 takes further X hours to reach its destination Q, while train 2 takes further Y hours to reach its destination, so called P. Then how to find speed ratio between these two trains? So that is what is mentioned here. If two trains T1 and T2 start at the same time from 2 points P and Q towards each other, and after crossing they take X and Y hours in reaching Q and P respectively, then the speed ratio between these two trains is given as under root Y divided by under root X. So यहाँ पर न्यूमरेटर में मैंने स्पीड ऑफ T1 लिखा है और डिनोमिनेटर में स्पीड ऑफ T2 लिखा है. सो यहाँ पर रेशो निकालते वक्त ऊपर में क्या आएगा, टाइम टेकन बाय ट्रेन 2 टू रीच इट्स डेस्टिनेशन, और डिनोमिनेटर में आएगा टाइम टेकन बाय ट्रेन 1 टू रीच इट्स डेस्टिनेशन, उन दोनों का अंडर रूट. प्लीज रिमेंबर दिस एक्सप्रेशन because this expression is nothing but a shortcut to find answer in some type of questions. Now let us try out one numerical based on this. Problem number 8. Two trains, one from Mumbai to Nagpur and another from Nagpur to Mumbai, start simultaneously. After they meet, the train reach their destination after 5 hours 20 minutes and 12 hours respectively. The ratio of their speed is, well, I can write it like this. So first train require further 5 hour 20 minutes, so called 5 1/3 hours to reach Nagpur after it crossed train 2, and train 2 further requires 12 hours to reach Mumbai. So here we need to determine the ratio of their speeds. We can straight away use that shortcut what we have discussed just now. Speed of train 1 divided by speed of train 2 is equal to under root of this 12 hours, and here in the denominator I will write under root of 5 1/3 hour. 5 1/3 is nothing but 16/3. So this comes out to be under root of 36/16, which is equal to 3/2. So the ratio of speed of train 1 and train 2 is 3:2. Option A is the right answer. Please remember this expression. This is a shortcut to find the answer in minimum time. So with this, all the concepts of train are clearly explained to you. I hope you understood it properly, and with this you can solve any numerical on trains which will appear in your competitive exam. Thank you for watching this video. I wish you all the best.